Welcome to Train Signal. You are watching Custom Recovery Plans. In this lesson on custom recovery plans, we will review recovery plan steps and how you can customize them. We will explore custom recovery options for virtual machines. We will reconfigure the network settings for recovered machines at the recovery site, including VMware methods for individual virtual machines, as well as for groups of virtual machines. We'll also cover non-VMware methods for reconfiguring the network. Finally, we'll discuss options to avoid custom network configuration altogether. And without further delay, let's get right into this lesson. A recovery plan completes a prescribed set of steps in a specific order. You can't really change the order of the default recovery plan steps because certain activities have to happen in a certain order, otherwise SRM doesn't work. A good example of this is that replicated data stores need to have snapshots created and then presented to the recovery site ESX servers before an SRM test can begin. Without this step, there are no virtual machines to test the recovery of, and therefore SRM won't work properly. But although there is a rigid set of must-have steps in a specific order, there are also still options to create a very flexible recovery plan. SRM allows us to insert commands before and after the base recovery plan steps. We'll explore options for these commands in more detail when we demonstrate custom VM recovery. These commands can be anything you can run from the operating system of the SRM recovery site server. Batch file, Perl script, VB script, but most popular moving forward will probably be the PowerShell script because of its high-level nature and it's easy to write or get a lot done with fewer code. We can also insert messages before and after steps to notify recovery site admins of key steps to complete or other actions to take. Think of a message as a pause in the SRM workflow with an accompanying message or instruction. A key feature of the recovery plan is that the virtual machines can be grouped by the priority in which they should be recovered. There are 4 priorities that a virtual machine can be: high, normal, low, and a no boot priority, or a virtual machine that doesn't boot up. The high priority virtual machines are booted first in a serial fashion. That is, one after another, with the second virtual machine not being able to boot until the first machine has completely booted up and its OS heartbeat has been restored. The OS heartbeat is what you'll get with VMware Tools, and once VMware Tools is up and running, the heartbeat is then restored so that the next virtual machine can go. The next group of virtual machines would be the normal group. I have it listed with low priority because they behave quite the same way, in that the normal virtual machines will not boot up until the last group has completely booted. But with both normal and low priority virtual machines, they'll boot up in a serial fashion per ESX server. So if you have multiple ESX servers, although you can only do one at a time on each ESX server, you'll be able to boot up multiple virtual machines on across your infrastructure, so one per ESX server. This can help speed up the recovery of the SRM recovery plan. So once the normal virtual machines have all been booted up, the low priority virtual machines would then kick off after the very last normal priority virtual machine has booted and its operating system heartbeat has been established. And then finally, the no boot VMs would be recovered, but obviously not booted up. Item of note here is that you really don't want to make too many virtual machines as a member of the high priority group. It will slow the time to finish the recovery greatly. And instead, it's a good idea to keep the bulk of your virtual machines in that normal or low priority group so that you can have multiple virtual machines booting up at the same time. Also, a key point to consider is that failovers, or the actual full recovery plan, has a different set of steps than a test recovery plan would normally have. but there's also some common steps that make up the core to both recovery options. I have this detailed in a table within the following slide, which I'll show you now. So we have three groups here. We have the both, which would mean both recovery plans. Then we have the test recovery plan column in the middle. Then we have the recovery only. So this would be the full failover. And we'll start with both because these are the steps that are done no matter which recovery plan we choose. The first step is initiate storage operations. So this would be taking and preparing the replicated storage and presenting it to the ESX servers. The second step is unregistering placeholder VMs and registering the recovered virtual machines. The third step is optional, and that is suspending local virtual machines that might have been used for test and dev to get some use out of that disaster recovery hardware. Those will be suspended at the recovery site to make room for the recovered virtual machines. Then we get into the priority groups. So we'll recover high priority virtual machines first, followed by normal, followed by low priority. Finally, we'll recover the no power on virtual machines or the no boot virtual machines. So in a test recovery, we've basically started with the steps we just listed. But at the very end of the test, we'll do these 4 steps that you would never do in a full-out failover recovery. And basically these are steps used to clean up the work done from a test recovery and prepare the SRM installation so that it's at full readiness to do a full recovery and respond to any disaster events that might happen. The first of these 4 events is that it's going to power off the recovered virtual machines that had been restored for the test recovery. It will then unregister these recovered virtual machines so that there's no trace of them in Virtual Center at the recovery site. Then it'll prepare itself for full disaster readiness, I guess, so to speak, by re-registering the placeholder VMs for the protected VMs. And then at the very end, it's going to clean up that replicated storage and get rid of the snapshots that had been used for the recovered VMs during the test. This is just to clean up the storage system and clean up the ESX servers on the recovery site. So again, they're ready to handle a full-out failover should the need arise. Now, if you're going to be doing a recovery only, so this would be pushing the big red button, doing a full-out failover to the recovery site. Everything is the same as the both column, except we start off with one very important step, which is shutting down of the protected site virtual machines. Why would you maybe want to do that? Well, this would be a specific disaster case where we have some warning in advance and we have a protected site that's still fully functional, but will be coming under either the risk of being shut down or will be shut down in the very near future. So what we want to do in this instance is shut down the virtual machines so that they can get their data in a known good state. And we'll let the underlying storage software replicate that last known good state of the protected site over to the recovery site. And then we can begin the rest of the recovery. In the case of synchronous replication, or what's another way to refer to basically real-time replication between sites, this is handled very easily by SRM, and that shutting down the virtual machines is really all you need to do to get that storage at a known good state. Now, if you don't have that luxury of synchronous replication and you use what's called asynchronous replication or replication of your SAN at predetermined intervals, maybe a couple hours or 30 minutes. In the case there, shutting down the virtual machines isn't enough to get the latest and greatest state of those protected virtual machines. What you'd also want to do in addition to shutting down the virtual machines is possibly trigger manually a stored replication to the other site so that you can capture the latest and greatest state of the virtual machines and not have any data loss during the recovery. Now, depending on the schedule, maybe the hurricane is still, a day away and we have all night to do this, you wouldn't necessarily need to do a manual replication. You could just wait until the actual replication schedule happen. Now, you might not have time to do all this within the SRM workflow. So you might actually do this manually or with some scripts. And we could talk about how you might introduce that into SRM later in this lesson. But as a takeaway, it's just good to know that if you have synchronous replication, then this process works as planned. If you have asynchronous replication or replication at predetermined intervals, some further thought and planning might need to be done to guarantee that there's no data loss in an actual failover. So before I demonstrate some of the steps, I'd like to just quickly overview some of the gotchas that can happen with custom recovery plans, or actually with SRM in general. It's good to be aware of the different timeouts that can affect you within SRM. The first one is the command line timeout, which is 300 seconds. And what this is basically doing is if there's command steps entered into the SRM workflow, if they don't finish within 300 seconds, SRM will continue on to the next step and flag them as an error that could be followed up later. Same goes with power state change timeouts. These are 120 seconds. So in the case of a failover, it might attempt to first power down running virtual machines at the protected site. If an answer isn't received within 120 seconds of that virtual machine being powered down, again, SRM would flag that as an error and move on to the next virtual machine. There's also recovery plan response times, which if you are setting up the recovery plan for the first time, you'll note that the default for these is 600 seconds. So for operating system heartbeat and for the time it allows the recovery plan to change network settings. In the case of not having VMware tools installed, you could see that there could be an obvious slowdown here. If you have multiple virtual machines with no VMware tools, that's 10 minutes per virtual machine. And that can add up fairly quick if you're trying to meet a predetermined RTO for some of your applications. RTO, again, being recovery time objective, which is how fast can I boot up and recover my environment. Okay, well, we've learned about custom recovery plan steps, the difference between fault failover and a test recovery plan, and some of the gotchas. But you really need to see this to fully understand it. So let's walk through a demonstration of what the steps look like, how we can change some of the timeouts, and how to add our own commands and messages. Okay, now it's time to go over the recovery steps demonstration. And we're going to cover the concepts that we just introduced about custom recovery plan steps and what our options are to create a flexible recovery plan. But first, let's review the base recovery plan steps that was presented earlier. Again, you'll find us logged in through the vSphere client into the recovery site virtual center. And the way we got here again was home and site recovery option there, or plugin. And if we look at the site recovery main level of the tree here on the left, you can then easily see that we're logged into the recovery site, since that's the local site, and the paired site is the protected site. So this would be done at the recovery site or your DR location. In order to see the base recovery plan steps, we'll want to select the recovery plan from the tree over here at the left. That brings us to this screen where we'll click on Recovery Steps tab. And what you'll see here is a set of base steps that get created as part of a default recovery plan. As we talked about earlier, not all of these are done if you're doing a test, and not all of them are being done if you're doing an actual failover. So it's good to know what's common to both recovery plans. That basically is steps 2 on down through 8. No matter whether you're doing a test recovery or a actual failover, you're always going to prepare your storage, which, as we talked about earlier, takes that recovered data store, that SAN replicated data store, and presents it to the recovery site ESX servers. The next step is suspension of the non-critical virtual machines. These would be virtual machines such as test and dev virtual machines that you're running at the recovery site to get some value out of that hardware that your company is invested in for DR, rather than just sitting there for tests and actual disasters that hopefully never happen, knock on wood. You could be doing dev and test to get some value out of them. But in the case of a test or an actual failover, you may require those resources to be available to do an actual recovery. So what we do here is suspend those virtual machines in order to save resources. After that, we begin with the actual recovery of the protected virtual machines. These can be arranged in 3 groups. There's a high priority group, a normal priority group, a low priority group, and a no power on group, or a no boot group. Now, the recovery of the high priority virtual machines happens first, obviously. And this could be your domain controllers, critical databases, possibly email. The thing that we pointed out earlier is that these virtual machines will boot up one at a time, regardless of how many ESX servers are in your environment. So be sure to put virtual machines here only if needed, because this can slow down the total time to recover. Once the very last high priority virtual machine is done, which we don't have here, but we can show that later and move some virtual machines there. But once it's done, we'll proceed into the normal priority virtual machines. These can be booted up in parallel on separate ESX servers, although only one virtual machine can be booted at a time on an ESX server. It then proceed to the low priority virtual machines, same rules as normal, and that a virtual machine can be booted up on each ESX server one at a time. No power on virtual machines would finally be registered with your environment and ready for you to do any activities you might need to do to get them ready. Maybe these are virtual machines that can't handle an automatic power on, and you haven't had time to be able to script the recovery of them in order to get them customized for the environment. So these might need some manual touch and feel to get ready to go in your environment. So those are the main steps. I guess it ends up with a message that says test is complete. You can verify when you're done. This is where things diverge a little bit. If we're doing a test, everything so far is described a test setup. But the next couple steps are only done in test and not in failover or the actual recovery. Those steps are the cleanup of the virtual machines post-test, which is number 9 here. What we're doing here is actually removing the virtual machines that had been recovered, removing them from inventory so that you no longer see them when you go back into a normal state. And it's obviously it's going to power them off before removing them. But that cleans up the inventory so it looks nice and fresh. Once that's done though, it would then, which we don't see here, but would re-register the virtual machines that were the placeholder virtual machines. Again, that placeholder virtual machine is used to notify the site recovery manager that there's virtual machines that are protected and ready to be restored. Those placeholders also store things like custom network settings and other things. That happens only in the test. Same with number 10 here, which is resume non-critical virtual machines. Once you're done doing a test, you'll want to obviously restart up the virtual machines that were running prior. So test and dev virtual machines would then get restarted. These could get technically started up after a true failover, but you don't want that automated in the SRM sense, since they're by design they're non-critical. So we shut them down, or we chose to shut them down earlier. Finally, there is the reset of the storage. So the replicated storage presented a snapshot to the recovery site ESX servers. We no longer want that snapshot presented to the recovery site servers because it's a point in time and we don't necessarily want those virtual machines to continue to be available to be booted from that storage. So what we need to do here is basically take that presented storage and unpresent it from the ESX servers, which would cause a rescan of the ESX box itself so that it sees that there's no more VMFS volumes for the replicated protected volumes. Again, the purpose of that is to prepare the storage for an actual failover and to get rid of snapshots that we no longer need, which can free up resources on your SAN. One thing I neglected to talk about here is when we talk about high priority, low priority virtual machines and how they boot up and how you control which one would boot next or when it would boot. We talked earlier about timeouts within the SRM plan itself. So there's the thing called recovery plan response time, which is looking at things like operating system heartbeat, which is the notification from VMware tools that it's good to go, or also the change network settings response time. The default for all of these is 600 seconds, and that's controlled by the recovery plan itself, which you can get to by clicking on this top left button, which is Edit Recovery Plan. And we'll click Next until you get to the section called Response Times. This is where you could tweak this if you've done testing and you found out that maybe you could do with a smaller time frame in the case of virtual machines that don't have VMware tools, and you've tested this and you're reasonably assured that virtual machines are booting in a good time. You don't want to wait 10 minutes for a machine that you know is booting reliably at, let's say, 2 minutes, right? So you'd want to change this down to maybe 300 seconds or 200 seconds. So in addition to the timeouts that we can tweak to help the recovery steps function at the right time, we can add a few things to kind of add some flexibility and do some custom things that you might need in your environment. So the first piece that we can add into a recovery plan is what's called commands or a command step. It's easy enough to find that. It looks like a little command prompt right here in the middle of this black dark thing with a green triangle. We go ahead and click on that, and actually I might cancel. Let's see where we're at. I'd like to maybe put a command after we've recovered the critical server. Notice we can't do any command steps inside of a priority group, but if I click at the priority group level, my commands are now highlighted. So what I'd like to do is run this right after normal priority. So I'm going to click down below and click command. And what you can do here is anything that can be run from the SRM recovery server at the command line could be entered into this section here. I so happen to have a batch script that I created that we're going to go ahead and put in here. Test critical server recovery.bat. Hopefully we typed that correctly. So as you can see, that inserted a additional step called number 6 here to call the command cscripts test critical server recovery.bat. All this will do is a simple batch script, which I can show you quickly, that will go out and open up Notepad and browse to a file share that's on a recovered server and try to open this text file called answertolife.txt. As an example, there it is, 42. In this case, it's working. Well, in this case, I'm actually contacting the live server that's already running. It hasn't been recovered. So this command script really isn't much good when I'm doing a test if I don't power down the old site. This actual script here would only be something useful in the case of a full failover when I've shut down the primary site, because this would actually run against the replicated critical server and go out to its file share to test that that file share was there. you can get as creative as you can get with your commands is really the limit to what you can do. You can have PowerShell scripts to change IP addresses or restart services. There's a lot of options, all of which we can't really cover in this lesson. But what I do want to do here is that I know that the command will work in a failover, but in a test scenario, how can I go in and test this? Now I could do some things with networking and whatnot so that the test network is accessible from the virtual center network. But for me, I'm pretty simple, and this is a simple test. So this is a perfect segue into helping me show you the next thing you can use to customize your recovery plan, which is called a message or a message step. So what I'm going to do here is click on the command line or the command line that we just entered, right? So that I know that it's highlighted. So any step I add is going to be inserted after the command. Well, since that command won't necessarily run well in my test recovery plan, and actually I'll back up. Why isn't it going to run well in my test recovery plan? We talked earlier about doing that test plan and that it created a bubble network within the recovery site vSphere environment. That bubble network securely fences in the recovered virtual machines. And we can't run scripts against it from an outside source without some networking kung fu. So what I'm going to do is add a message step, which is the third from the left here, the one right next to the command. Go ahead and click that, and similar as before, except now I'm not putting in code, I'm actually putting in or typing in a message to myself to notify myself or another recovery admin what to do when they get to this portion of the recovery plan. In my case, it's going to be manually test that critical server file share was recovered successfully. Thanks. You can do whatever you need here. It's good to be concise and simple and not overuse these. But this message will actually pause the SRM recovery or the test at this specific spot and wait until there's been feedback from the administrator to move forward. Okay, so that does it for the recovery steps demo that I wanted to show you so that you could see what the actual recovery steps look like and how we could add command steps in to add functionality from specific scripts, and how to add in custom messages to pause the flow of the recovery plan and notify the administrators of other activity to do. Okay, in addition to looking at the custom recovery steps, there's also the option to take a virtual machine and move it into a different priority grouping. If we take a look at critical server here, critical server realistically needs to be up and running prior to critical PC, since the PC is the user access tier, so to speak, and it needs to access the server. Well, if the server isn't up fully yet, we'll have issues. So what we'll want to do is raise the priority of critical server. To do that, just right click on the virtual machine within the recovery plan steps, and you have the option to move it up or down. I'm going to choose move up. You can see it's now moved it up one step, and it's now underneath the high priority virtual machine section. If you need to move something up a lot of steps though, there's no other way to do it but then to continue to click move up and down. In future iterations of VMware Site Recovery Manager, we're hoping that we'll be able to drag and drop multiple levels of steps. As you get dozens and sometimes hundreds of virtual machines in your recovery plan, moving them up one by one could be a laborious task. But that's how you can change the priority of the virtual machines, and I'll go ahead and move one down into the low priority group just so you can see what we have going on. Okay, now let's discuss options for customizing the recovery of virtual machines at your recovery site. The needs for VMs at the recovery site are different than those at the protected site. So you'll need to create a game plan for reconfiguring VMs so that they can successfully operate in the different environment. In environments with fewer resources at the DR site, it might be necessary to tweak the amount of virtual resources allocated to your VM. This could be things like removing memory from the VM or possibly removing the number of CPUs, maybe down from 8 to 4 or from 4 to 2. The reason you might consider doing this is that although your protected site has adequate resources to function at a high level of performance throughout the day, a disaster recovery site might not be financed appropriately to do that. So this is a good way to make the most of your resources and provide some level of recovery for your business. Maybe not 100% function, but it's better than nothing. A way to automate removing of those resources could possibly be an SRM command step that calls a PowerShell script that could then in turn connect to the virtual machine, power it down, and remove these resources. One of the more common customization steps is that of changing the network settings. And that is to make sure that the virtual machine has the correct network identity to function properly in the different environment at the recovery site. See, we can replicate data and boot the virtual machine, but if you can't access the VM and its data via the network, then you haven't provided much value that could be experienced with SRM. So we need to make sure the network piece is configured properly for the new data center. This usually comes down to the IP address, possibly the subnet mask, most definitely probably a different gateway, and the DNS servers may or may not be different. If you had DNS servers at the protected site that are no longer available because of the disaster, we might not want to then include them actually in the reconfiguration. Also, computer name and fully qualified domain name should probably not have to change since you're used to accessing them that way and most apps are as well. So we shouldn't have to worry about that. But we will have to make sure that the DNS server gets updated with the new IP address that we configure. If your DNS server doesn't support dynamic updates, you'll want to make sure that we consider adding a manual step within the SRM recovery plan steps to possibly notify the administrator that DNS would be something they need to change. So we know it's important to change the network, but what are some of my options for changing the network settings upon a recovery at the new site? Well, there are many, but we're going to focus on 4 main options or types of network reconfiguration. The first would just be plain old manual configuration. Here you would just wait until the VM is booted and then log into the VM console. Change the IP through the standard tools that you would use with your operating system. This step could also be automated with your favorite flavor of script foo that you practice. But remember, the network visibility from the vCenter server into the VM might be an issue when you're trying to have your script talk to the VM over the network. So this would be something that you'd want to think about carefully prior to configuring. Second option could be DHCP and have that IP address dynamically assigned to the VMs. The replicated VMs could use this DHCP to get their address, but care should be taken in configuring this so that the correct IPs get assigned to the correct VMs. Or if nothing else, maybe you don't care about the VM, or excuse me, you don't care about the VM's IP, you do want to make sure that the correct DNS entries get updated with the new IP addresses now assigned out through DHCP. The third option is the one that most people would start with, especially in a small environment because it's the easiest and possibly the most familiar, and that is using a VMware guest customization specification. It's the method that we'll use to demonstrate in this lesson. Folks familiar with deploying VMs from templates and then using guest customization to configure a computer name, the operating system ID, the IP for a Windows virtual machine would be familiar with this option. Guest customizations are done on an individual basis, and they leverage the sysprep configuration files. So you'll want to make sure that the sysprep files get copied in to the correct location on the vCenter server. I'll quickly show you those when we go to demonstrate that process. Otherwise, the vCenter server administration guide is a good place to learn about this, or you can look at refer back to some of the other Train Signal Pro Series VMware videos that talk about some of the same options, and they would probably show you there too. So, like I mentioned, this is on a per VM basis. So you'll need a guest customization specification for each VM. You could see how that could get very big over time, and since SRM can go up to hundreds of VMs, having hundreds of individual guest customization files could be quite tedious to work through and to keep current. Because of this, VMware created a utility. Right now it's just a command line utility that can be used to run against your virtual machines to report back what their IP addresses are. And you can also use another utility to customize a group of virtual machines and their IP addresses. So if we're working on a very large SRM deployment, that utility would be something you very much want to look into. It's titled by its name, which is drip customizer.exe. Now this is a utility that you can find within the Site Recovery Manager's program files directory. You have the reporter exe, which can be used to report on it, and then the IP customizer, which is used to configure the IPs for the VMs. Well, that does it for this lesson. We'll now dive into the demonstration of custom recovery options for VMs. Okay, here we're going to demonstrate some options for preparing a VM customization specification and create the plan to map IPs from the protected site into the IPs needed for the recovery site. To get started, let's head back to the home screen. As you can see up top, I'm on the recovery VC, so we're doing this configuration from the recovery site. Once I'm at the home screen, I'll need to create a customization specification. We do that through the Customization Specifications Manager location. In here I don't have any currently. I could have copied from one and edited a little bit so that we didn't have to recreate the wheel, but we'll go ahead and do that now. Click New. It is a Windows OS. We could do Windows and Linux. We're just going to do Windows right now. And I'm going to call this one Critical Server, since it's the customization for Critical Server. I'm going to make a designation that this is for SRM. Actually, I'm going to do that right at the beginning so that they sort nicely. I'm going to have to enter some information so I can proceed. This isn't necessarily used in the SRM sense of the guest customization wizard, so we're just going to quickly enter in some options that make sense. I'm going to use the virtual machine name. Again, this is all dummy information. And the only thing of consequence when used for network reconfiguration is that we have the correct network stuff, or excuse me, the correct network information entered into the specification here. Go Central Time Zone. Great. Now we're at the network settings. This is really all that needs to be configured, and it's the most important. So since this is the critical server that we're mapping, I want to make sure that I give it a custom setting, since I'll be manually configuring the VM. I click Next earlier, and then I highlight this, and there's a little box here with two ellipsis dots. Go ahead and click on that, and that brings up a form that you can use to enter in the network settings that you need. I'm going to use a static IP address in the recovery site, although I could use DHCP. I'll refer back to my mappings. My critical server is .61 at the protected site. I'm going to change it to .81 at the recovery site just to demonstrate the ability to reconfigure networks. If you've been paying attention, you'll realize that this isn't on a different network at all. This is just a lab setup. So I don't need to change anything. And changing the IP actually is just for giggles here to demonstrate the capabilities of the guest customization. So once I've entered in the IP addresses that I want assigned to the recovered VM and verify that they are correct, I'll go ahead and click OK. Then click Next to work through the rest of the wizard and finish. I now have a guest customization specification that I can use later. Actually, before we do that, let's create what we'll need for a critical PC as well. Okay, I enter all that dummy information so I can at least get to the network portion here. Once I'm here, I can click Custom Settings, Next, and again, I'll highlight that option for the NIC that I have, and click the box with the ellipsis dots, then enter in the IP address that I would like to see configured for this PC when it's recovered in the recovery site. That is a virtual PC, actually. And I'll quick verify that I got the right mappings down there, 62 to 82. Looks like I got it in there correctly. So I'll go ahead and click OK. Next, next, and finish to get through those last few screens of dummy information. All right, so I got two guest customizations here. And to apply these to VMs, we'll go back into the SRM setup. To do that, we go to Home and Site Recovery. Again, you'll get tired of me saying this, but I always like to see where I'm at to make sure I'm configuring the correct site. Local site is recovery site. We are in the right spot. So to add that customization specification that we just created to a VM, we need to go into the recovery plan. And we're already at the virtual machines tab, but you might end up here at summary first, to which you want to go to virtual machines. You'll highlight the virtual machine that you want to customize on the recovery, then click Edit. And the very first screen is the option to choose a customization specification. To do so, we will click the Browse button and find the specification that we just created for critical server. Remember that this is a one-to-one mapping, and I don't want to use the PC specification against the critical server. That would give it the wrong IP. So I click OK. I could give it a description if I wanted to, but I won't. We'll go ahead and click Next now once we've chosen the specification. And you'll notice here that we got a couple steps that we've added pre-power on. I'm going to go ahead and remove those. If you're curious, you could add in a message that says pre-power on. Notice we will be changing the IP address. Please be patient. Anything could be entered in there, actually. So we'll click next. Post power on, same thing could be done here. Maybe we'll add a message that says, please check the IP address for correctness. Should be 192.168.2.81. Now this might be a little overkill, but nothing else. I want to throw some message in there to show you that it could be helpful in managing your workflow. Actually, having a message in there earlier said all done. I might move that down actually. So I highlight it and I click on the move down button. That has the effect of moving it down. So click finish when you're done. We have one more specification that we'd like to add. So click on critical PC and edit. Other than the names of your VMs that you're testing will obviously probably be different, but in this case, I'm using critical PC. I will browse out to the specification created for critical PC and highlight it and click OK. Click next to move forward. I'm not going to mess with messages or commands at this point. Finish and close. There we go. That's really all there is to putting in the guest customizations. What would be ideal though is that we possibly test those customizations. Okay, so we talked about some options for reconfiguring VMs to meet the needs of their new environment that they live in, but it's also a good idea to talk about some options to avoid having to reconfigure those same virtual machine networks. One of those that we did talk about earlier, which technically is a reconfiguration of the IP, but it doesn't have to change the VM's configuration, which is DHCP. So once you've configured a VM for DHCP, you don't have to configure it again. It's when it boots at the second site, it would then look for a DHCP server to get its IP configuration and all that. So using the choice to use DHCP would remove the complexity from the SRM configuration into the DHCP configuration, and administrators of that system would then have to make sure that virtual machines, when booting up in different sites, would get the correct configuration information. And as always, you're going to have to make sure that DNS gets updated correctly if you're going to use DHCP. But I mention it here because it is sort of a simplification of networking, and it does avoid you having to change the VM before booting. So yeah, as I mentioned earlier, bringing up VMs in one environment in another, or bringing up the VMs from one environment to another completely different one is a complex undertaking. And it should be avoided to have to reconfigure those VMs if we can. One way to avoid that and to kind of punt the problem somewhere else is to stretch a common layer 2 network between sites. And a way to do that traditionally has been by stretching a VLAN from one site to another. This is a specialized switch configuration that can create a virtual LAN from one piece of switching hardware to another at a remote site. Now, although you can do that, you maybe shouldn't do that, and we'll talk about some of the pros and cons later. The other most recent addition to options for creating a layer 2 network between many different sites is that of Cisco OTV, or Cisco Overlay Transport Virtualization. This is a pretty exciting technology that has just come out, and to my knowledge is the only one on the market today providing that type of feature. But really what it is layer 2 networking delivered over layer 3. So you can actually take a virtual machine and it can have a layer 2 identity and it can be routed on top of layer 3 networking, so TCP/IP. Therefore, you can keep your IP addressing the same at all the different sites and keep some of the features and functionality of having that flexibility, right? But you can have specialized high availability VMs that would be protected by SRM in a Cisco OTV virtual network so that we don't have to go through the trouble of restoring their virtual machines networking settings for a different environment. The final option that could be used to avoid reconfiguring VMs is using NAT, or network address translation. This would be done by some sort of load balancing server or firewall that can talk NAT, and that's put in front of all the virtual machines, which is pretty useful in that it reduces the need to reconfigure VMs, but it kind of increases complexity since all traffic has to go through that NAT layer in order to get to the VMs, which can reduce the performance of the solution. I see this being a great option though for internet workloads or workloads that are accessed from the internet. So web servers, maybe it's your company's mail server. Great options here because typically you're going to be connecting to those servers from your remote device, from your laptop, from a remote office. So they could care less whether that server is on the same network as they are because they're all on completely different networks. They're just looking for an IP. So having a NATed address so that when that mail server switches over or gets recovered at the recovery site, they're none the wiser that there's a NAT device in front of them. That's good information, but it'd be nice to maybe visualize what we're talking about here. I just whipped up a quick diagram here to show you what it would look like if you can't take a layer 2 network and stretch it across two sites. You can see on the left we have our protected site, which consists of a data center, and we have a class B network here, a 10.2 network, and some virtual machines that live on that side in the protected production environment. And those virtual machines are replicated through the magic of SRM and SAN replication, and they end up at the recovery site, which has a completely different network. 10.99 is the network over there. And in a red box here, I draw red because it's difficult and complex to reconfigure. Those virtual machines all have to be reconfigured in order to come up. So there's some complexity inherent in a two-network setup. However, if we can stretch that layer 2 network across the two sites, we can still have SRM in the background, leveraging SAN replication to replicate the storage bits and bytes to the other side. And we have SRM to then automate the recovery in a specific order at the recovery site. But now we've completely taken that network reconfiguration issue, and it's no longer. Because of the work that we've put into the foundation for having a layer 2 network span two sites, we can now, I guess, harvest the fruits of our labor and use SRM and completely boot those virtual machines without having to do anything to them. So that's a great benefit. As you can see, it's pretty easy to visualize having a single network over two sites. Although there are a few pros and cons with setting up a common layer 2 network across sites, and basically with a stretched VLAN approach, which you can do with most enterprise class switches today. Cisco's and HP's can all do this sort of thing. The pro is simple. It's just as you saw earlier, is you got a common layer 2 network. We don't have to go through network reconfiguration with SRM, so that's good. There are some cons with doing a layer 2 network with stretched VLANs. It's inflexible in that it's It can be a little bit hard to configure for multiple sites, and it's really not built for this type of purpose for SRM. But there's also no specialized intelligence to handle broadcast, multicast, or spanning tree traffic between sites. It truly is a stretched VLAN across networks, and without the intelligence of sites being further apart. So although it is helpful in creating a simple network configuration, it's also not necessarily something that you'd want to deploy in a widespread fashion because of the lack of intelligent features to provide, let's say, site-specific intelligence to networking. Cisco OTV, on the other hand, has the exact same pro. It's a common layer 2 network across sites. However, it also preserves the layer 3 hierarchy within your network, and that each of your remote sites can continue to have its own networking addresses underlying everything. So routing and firewall access and access to internet can all stay exactly the same way that it's been. Voice traffic could be the same way. However, there's a smarter handling of the multicast and the broadcast and the spanning tree traffic that brings a site intelligence to the switches controlling Cisco OTV. I don't want to make this a Cisco OTV commercial. You can definitely go online, cisco.com, and Google for Google for Cisco OTV, and look at some of the information on it. But it is an emerging technology that would greatly simplify SRM as far as, and also lay down the foundation for future VM mobility technologies that allow VMs to move between sites. The major con, though, with Cisco OTV is today it requires specialized Cisco hardware, which most likely comes at a premium price right now. So it might not be within the grasp of the small and medium businesses out there, but I mentioned it anyway so that you can keep it in your list of technologies to consider when simplifying your site recovery manager design and architecture. Well, that does it for this lesson on custom recovery plans. Before we go, let's quickly review what we've learned. First off, we covered the recovery plan steps that are both common to the recovery test and to the actual failover or production recovery, so to speak. And we talked about how you can customize those recovery plans with custom command steps and custom message steps. We also explored the custom recovery options that would exist for each virtual machine and some common things that you would want to do in a recovery site when bringing up virtual machines. This included doing things to reduce the amount of resources allocated to individual virtual machines in the case where a DR site doesn't have the available capacity to host a 100% performing environment. But mainly we focused on the reconfiguration of network settings for the recovered virtual machines at the recovery site. We focused on VMware methods for individual virtual machines and groups using the VMware customization specification in order to create a specification file that can use Windows sysprep to reconfigure the network settings for the virtual machines. We also highlighted some non-VMware methods that might be of use to you, whether you're scripting or using DHCP. And finally, we focused on a few slides to talk about options that you could explore to avoid having to have custom network configuration within the SRM environment. These would be options to greatly simplify the overall amount of moving parts that SRM is responsible for, and let it focus on what it does really good, which is restoring virtual machines in a certain order and controlling the SAN replication underneath to actually replicate the virtual machines. Well, that's all for this lesson on custom recovery plans. Thanks for watching, and I'll see you in the next lesson.